Evening. All right, so we're continuing our study of apologetics, and tonight what we're going to be talking about is Earth, the privileged planet. This is our second part of the teleological argument. So the last time we talked about how incredible and finely tuned the universe is. Now, again, all that we're talking about right now are theistic arguments, or arguments for the existence of God. And keep in mind that this is a cumulative case that we're building that God exists. None of these need to stand alone. None of them need to stand on their own as being the one and only way that you can bring someone to God. So everybody is going to be a little bit different. For people who are very scientifically minded, the cosmological argument or the teleological argument may be the more important, but for someone who is maybe more philosophical, it may be one of the other theistic arguments. And like we talked about before, because it has been a couple weeks, so just as a reminder, teleology or the teleological argument comes from the Greek word telos, which means goal or purpose. And it's oftentimes now called the argument from design. And as we've said before, Romans 1, 19 and 20 tells us that basically everyone knows God exists because of the beauty that is around us. Again, also remembers two different types of arguments, deductive and inductive. And in this case, in all of the teleological arguments that we're going to talk about, we're talking about an inductive argument, which means it's an inference to the best explanation. And specifically, we're talking about an argument by analogy, which basically says because two things are similar in one way, you can say that they're similar in another way. So a perfect example of that is the watch argument. A watch exhibits order, function, and design, and we know that a watch was made or created by a creator. The universe exhibits order, function, and design, and therefore the universe was probably created by a creator. That chance is not what likely caused the universe to be the way it is. We also talked about the fact that with the fine-tuning argument, it actually does come in a more deductive manner, and that is that the fine-tuning is either a result of necessity, chance, or design. If you stop and think about it, there is no other way that the universe could be the way it is. It's either that way necessarily, meaning it has to be that way, or it's there by just random chances, which is what an atheist would tell you, or it is designed. And we're going to say it's not the result of chance or necessity, therefore the data are a result of design, therefore there's a designer. And that's the teleological argument. Now, last time we started big, really big, and that is we started with the universe itself. And we ultimately ended up saying that the probability that the universe occurred randomly, in other words, with no conscious creator involved, the way it is with all of the finely tuned forces of the universe, like the gravitational constant and weak nuclear force and the strong nuclear force and all of those, the cosmological constant, is 1 part in 10 to the 10th power to the 123rd power. Now, Oxford University mathematician Roger Penrose says the number which would be impossible to write out in the usual decimal way, because even if you were able to put a 0 on every particle in the universe, there would not even be enough particles to do the job. Now, that alone is just incredible. To me, at that point, you can stop. You don't need to convince me any further. Some people need more convincing. So tonight, we're going to talk about Earth and how it is a privileged planet. And the reason I call it that is because these two scientists, Jay Richards and Guillermo Gonzalez, both of whom are active, working, researching, publishing scientists, published a book a few years back called The Privileged Planet. And in it, they talk about a lot of the things that we're going to talk about tonight, about the amazing things about Earth. Now, one of the things I want to get across to y'all is a twofold thing about that. First, it is incredible the way the Earth has been designed to bring about life. But the other thing that's incredible about Earth and some of the things that we're going to talk about tonight is the fact that Earth is not only incredible, but it is placed in an absolutely perfect location to be able to observe the things about the universe that scientists are able to observe, to even be able to study what we can study. So it's not just that it sustains life, it's that it sustains life and enables us to look at the entire cosmos around us. And it's absolutely amazing. Now, all of us at some point have probably been out away from light pollution enough that we've looked into a night sky and this is the picture we've seen. So everybody knows what this is, right? This is the Milky Way galaxy. It's the galaxy that we are in. Now, the Milky Way galaxy is a very interesting galaxy. It is a spiral galaxy, okay? Meaning that it actually has spiral arms coming off of it, much the same way as a pinwheel that little kids blow into and you see go around and around. Now, it is kind of a medium-sized galaxy, and of course it is one among many, many, many galaxies. Now, a couple of things I'm going to point out about this. In the center, you see there that it's very dense in terms of light. Now, it's not only dense in terms of light, it's also dense in terms of particles, simple random particles that exist there, okay? As you go further and further out, of course, there's less and less particles. However, there's also less energy, and the types of stars and planets that are in the outer aspects of the galaxy are different than those more toward the middle. Now, we are here, and one of the things that I want you to notice about where we are is we actually sit in between spiral arms of the galaxy. Well, it turns out that's really, really important, especially for our ability to observe the universe around us. You see, if we sat in one of the spiral arms, and I'll bring us to the next one, we actually sit between the Sagittarius arm and the Perseus arm. Our sun actually sits in kind of almost a mini arm there, but it sits in between two major arms, Sagittarius and Perseus. If we were in one of the actual arms, a couple of things would be different than what they are the way we are and in the position we are. First of all, there are many more stars within the actual spiral arms of the galaxy. So if you stop and think about it, there's more light around in those areas. Thus, our ability to look at the rest of the universe around us would be somewhat inhibited. The best way to think about that is if you live in New York City and you try to look up to the night sky and see the picture of the Milky Way that we saw earlier, you're not going to see that because of all the light pollution. The same is true kind of from analogy in terms of where we lie in the galaxy itself. The other thing is there's much more cosmic debris in those areas. So our solar system and our planet itself would be bombarded by many more particles, making life much more difficult. Okay? The other thing is we're kind of, if you notice, fairly central between the center of the galaxy and the outer reaches of the galaxy. Again, that's important in terms of what kinds of stars exist and other aspects of our star more than anything else, the sun. Now, the other thing that's interesting is our galaxy is actually fairly flat. It's not a globe or a dome or a ball. There are different types of galaxies, and as a spiral galaxy, ours is a relatively flat one. And in fact, it even has this kind of warp to it. So it's not a completely flat disk, it's more of an arc. If you look there, you see where our sun is. Now, mind you, our sun is about 26,000 light years from the center bulge of the galaxy. Again, our position there, as you can kind of see from this look at it, instead of looking at it face onto the disk, you look at the side of the disk, you now can see why it is that our position in the galaxy makes it so important for being able to observe the entirety of the universe around it. If we were in a globe-type galaxy, then we'd have a much harder time observing the rest of the universe. Again, we'd have too much difficulty with seeing all the other stars and light and debris around us. But because we sit in a fairly flat galaxy and we sit far enough out from that center, we can see the universe around us. Isn't it amazing that where the only place that we know of that life exists is in a prime position to be able to observe the universe around us? It's an incredible thing. Let's look at our sun for a moment. So first of all, our sun, there's many different types of stars. As you know, our sun is a star. It is called a yellow dwarf star. It's a relatively small star. Now actually, for yellow dwarf stars, ours is actually a fairly large one. So yellow dwarf stars are anywhere from about 80 to 100% the size of our star. So our sun is in the bigger range of yellow dwarf stars. One of the important things about it is the amount of heat that it gives off. Heat is an incredibly important part of life for us. Why? Because water is a very important part of life for us, and we'll talk about that more in a few minutes. But without water, there is no life. Well, if the star is too cold, all the water is ice. And if it's not in liquid form, it's not the solvent we need it to be for life, and life doesn't exist. If it is too hot, all of the water exists in gaseous form. Again, doesn't work the same as a solvent, you don't have life. So that temperature range of about 5,300 to 6,000 degrees Kelvin is very important for the existence of water in liquid form, therefore the existence of life. It's also got a relatively large amount of heavy elements in it, which tells us that it's actually, it's not a very new star. Very new stars have almost no heavy elements in them. They're almost all hydrogen and helium. Kind of middle-aged stars, as they put it. They oftentimes will say that our star is a middle-aged star. They have more heavy elements, which tells us that they're in part, they've gotten some breakdown products from other stars that have kind of come and coagulated into the star itself. Let's start looking at some of the real fine-tuning in terms of the moon, the earth, and the sun. The first thing is this. There's some very interesting ratios if you look at the size of our moon and the size of our sun and the distance of the moon and the sun from Earth. Have you ever looked into the daytime sky and noticed the size of the sun? Fairly small, right? Look in the night sky. The moon, in a full moon, is the same size as the sun. They may say, how the heck is that even possible? We know that the sun is far larger than the moon. Well, it turns out the sun is actually 400 times larger than the moon. It's also 400 times farther away from the earth. Now that does two things. Number one, it gives us that look to where if you look in the night sky at a full moon, you see it as the same size as, say, the noonday sun. The other thing it also does is it enables what they call a perfect solar eclipse. Now, you may say, well, why is that important? Again, remember, the two things I want to talk about is how incredible the earth is for sustaining life, but also how incredible it is that we can then observe the universe around us. It turns out perfect solar eclipses, and they don't occur very often, but perfect solar eclipses actually enable scientists to look specifically at certain things in the galaxy and in the universe that have been able to prove some of the scientific theories that have been put forth by some of the world's greatest scientists. Remember, I believe that science and Christianity are not against each other, but actually work hand in hand. To me, science, in fact, can't be done without God, number one. And number two is our attempt to understand the inner workings of what God has put together. Okay? Well, in a perfect solar eclipse, when you get a vision like this, which is what you see, there's a couple of things you see. You see the solar flares around it, but what they've also been able to do is observe the bending of light of distant stars as predicted by Albert Einstein. Remember, Einstein said as part of his theory of relativity that light didn't just go straight, it would actually be bent by gravity. And one of the things that they've been able to prove is that Einstein, in fact, was right because of perfect solar eclipses. So if the moon weren't exactly the size it was, and exactly in the ratio from the Earth compared to the sun, we'd never be able to observe those things. Isn't that incredible?
Wow.
It's amazing. Now, The moon, we all see the moon in the night sky. We know about the different phases of the moon and everything. But what a lot of people don't understand is how important the moon is to life on Earth. The first thing it does is it stabilizes the axis of rotation around which the Earth rotates. Now you may say, well, why is that important? Well, it's actually super, super important. I'm actually going to skip to this slide. It's super, super important in terms of seasons. You see, if the Earth weren't on the exact tilt that it's on, or one very close to that, and it wasn't stabilized by the moon, first of all, you would get a lot of yaw as it was spinning. That would really affect seasons a lot and could end up causing there to be far too hot or far too cold of seasons. In other words, two radical changes from winter to summer. Okay? Remember that tilt is actually what enables us to have 4 seasons, and the northern hemisphere, remember, is actually the exact opposite of the southern hemisphere. When it's winter here, it's summer there. When it's winter there, it's summer here. That tilt is what enables that. And that tilt is stabilized by the moon. You see, if you look at the moon and the size of the moon compared to Earth, it is actually far larger than almost any other moon compared to its planet anywhere else in the solar system. You look, for instance, at the moons of Saturn and the moons of Jupiter. They are far smaller than the planet are. But in the case of the moon and the Earth, the moon is actually quite large compared to the size of the Earth. Now I'm going to back up one. We also know, of course, about the effect of the moon on tides. Tides are incredibly important, especially in terms of marine life and the renewal of the sea. They're important also for the rotation of waters that help to stabilize the amount of ice versus liquid water on Earth. These are all incredibly important things to life because remember, water is the key to life. If you don't have water, you don't have life. That's why all of the space exploration that we've done and all of the attention that we've done or put into whether or not there's water on Mars. Why? Because we know that if there's water, there's the possibility of life. But if there's no water, there's no possibility of life. Okay? We've already gone over that slide. Now, in order to have life, you also have to have a terrestrial planet. In other words, a planet that has a large amount of land and water on it. Well, it turns out there's only 4 terrestrial bodies in our solar system, and that are Mercury, Venus, Earth, the Moon, and Mars. It's the only ones. All the other planets, many of the other planets like Jupiter and Saturn, are predominantly gaseous planets. We are a terrestrial planet. You have to have a terrestrial planet in order to have life. Now, a couple of things that come along with that. Not only do you have to have a terrestrial planet, but you have to have one that has plate tectonics. Now, this is where sometimes you will have Christians and scientists that will start to butt heads about plate tectonics. Because we all learned in school how, originally a bazillion years ago, there was one land mass and it broke up and all this kind of stuff. Honestly, I don't even care about any of that. That's not what we're talking about here. But plate tectonics, the movement of those plates around each other, is part of what creates volcanic activity. That volcanic activity is incredibly important in the carbon cycle of the Earth. Now, why is that important? Well, number one, there's 2 things that you got to have for life. You got to have water. You also have to have carbon. Okay? If you look at any of the building blocks of life, amino acids, proteins, any of those kinds of things, what do they all have in them? Sugars as well? Carbon. We are carbon-based life forms. So you have to have that carbon restoration. Also, look at what it actually gives you. It gives you CO2 gas. Remember, plants use CO2 as their fuel in the same manner in which we use oxygen as our fuel. So part of what plate tectonics does to allow life is it helps to recycle the carbon. Without plate tectonics, we wouldn't have that. We wouldn't have volcanoes, and we wouldn't have that restoration of the carbon levels in our atmosphere, and therefore life would become much more difficult, if not impossible. The other thing you have to have is you have to have a planet that has an inner core that is heavy metal like ours. It has to do with the gravitational aspect of the Earth and how we actually stay on Earth. Remember, we talked last time, if the gravitational constant were any different, then life wouldn't exist at all. In part because things like water wouldn't stay on the Earth enough to have liquid water and enough to have life. So you have to have that electromagnetic force of a molten iron core in order for us to sustain life on Earth. Let's talk specifically about water. Water is an amazing molecule. It's an absolutely incredible molecule, and it is so much different than so many other solvents in the world. We all know H2O is water, right? That's some high quality H2O, right? We all know that. But remember, again, water is the source of life. There's some pretty amazing things about water. Let's take those first four: surface tension, adhesion, cohesion, and capillary action. Now, part of the way that we get some of the sand that we get, and we get erosion of mountains, is that water, through those first four properties, actually leaks down into small areas in rocks. And as it freezes, it actually starts to break rocks apart. Because we all know that it's one of the few solvents out there that actually is larger as a solid than it is as a liquid. Almost all the rest of them, as you go from solid to liquid to gas, of course, it goes up in size, but not water. Water is larger as a solid. It has to do with its crystalline structure. It has a neutral pH. Why is that important? It's the universal solvent. Now, the next thing we're going to talk about, though, is its lower density as a solid. Have you ever stopped to think about the fact that it is, if water didn't float as ice, then much of the marine life that we know of wouldn't exist? Have you ever thought about that? Let's take a pond for a moment. We've all seen, movies. We all live in the South, so I've never actually seen it myself, but we've all seen movies where people go ice fishing, right? How does that work? Well, the ice freezes on top, but because it is less dense than the liquid water underneath, it stays on top. Okay? They drill a hole in it, and they could still fish in it. Now, if you stop and think about how amazing that actually is, if ice were more dense than liquid water, what would happen? It would sink. As it sunk and got to the lower and lower and lower levels, especially in things like the ocean, would it ever melt again? No. Because as you get lower and lower and lower and lower in the ocean, it gets colder and colder and colder and farther away from light and heat from the sun, and it would just continue to freeze and freeze and freeze and freeze and freeze. Pretty soon it would start wiping out some of the marine life. The same is true in lakes and ponds. It actually insulates the water beneath. If you've ever done any kind of survival training, what do they tell you to do if it starts snowing and you don't have enough warmth? They actually tell you to burrow under the snow because it's actually warmer under there than it is outside of it, right? That's the way igloos work, as an example. So it is an amazing property of water that is actually lower density as a solid than it is as a liquid. It's the only liquid I know of that's the case. To my knowledge, I don't think there's any other. So you stop and think about that. If it were not for that property of water alone, life might not exist. Isn't that amazing? Now, the other thing is our position within our solar system. Believe it or not, our position within our solar system is incredibly important for protecting the life that does exist. Now, it doesn't permit life, it doesn't allow life, but what it does do is protects us from the cosmic world around us. And you may say, well, how is that? Well, it turns out Jupiter and Saturn, that are so much bigger than our Earth is, actually protect us almost like a vacuum cleaner. Remember, the pull of gravity is proportional to the size of the object, right? That's partly why our weight here on Earth is heavier than it would be on the moon. Well, the gravity of Jupiter and Saturn are so much heavier than the gravity of Earth that as asteroids and other debris from outside of our solar system in other portions of our galaxy start to come in, they get sucked in by the gravity of Jupiter and Jupiter and Saturn actually protect us from a lot of the cosmic debris that could actually bring about an end to life on Earth. So even our position and the fact that we have larger planets outside of us is so important to the existence of life here on Earth. So when we start to look at all this, and I know this has been a little bit shorter session than we often have, but trust me, the next one's going to be longer. We go back to our fine-tuning argument, and we say that all of those things that we just talked about with life and Earth and how amazing our privileged planet is, fine-tuning is either the result of necessity, chance, or design. I would tell you that when you look at the presence of water, the properties of water, the place of our star in our galaxy, the place that we are from our star, because let's keep in mind, if we were closer, everything would be gaseous water. If we were further away, everything would be frozen water. The presence of Jupiter and Saturn to protect us, and the presence of our moon being the size that it is, stabilizing our atmosphere and our tidal pools. When you look at all of those things, I, for one, can't say that that's the result of chance. Therefore, I have to say this is the result of design, and therefore, there's a designer. With that, I'll open it up for questions. All right. No questions. All right, next time what we're going to cover is we're going to cover the origins of life. What does it mean to have life? And how what it means to have life leads me and other scientists to say that it could not be done without a designer. Because despite what many people will tell you, we are no closer to coming to a scientific explanation for the origin of life than we were in the time of Darwin. And quite frankly, in many ways, discoveries since the time of Darwin have actually done more to debunk the theories of Darwin than they have to support the theories of Darwin. So that's what we're going to be talking about next week. Okay? We hope that you enjoyed the content of our video today. If you did, make sure to give us a thumbs up and share this content. Also, don't forget to hit the subscribe button and hit the bell so that you are alerted to any new content that we post on our channel. Please remember that all of our video content is completely free of charge and can be reposted, shared, and embedded. You can also find us on Facebook at facebook.com/armorofgodapologetics with an S. Thank you for watching and have a blessed day.